Hi and welcome to Vulkan from Zero to Hero.
In this section, we are going to draw our first triangle.
In this video, we are going to create semaphore. Welcome back. In the previous video, we successfully created depth buffer. It's time to create semaphores. In the next generation of GPU APIs, we have 4 synchronization types: fences, semaphores, events, and barriers. Fences being used to send signal to the application, for example, the execution of command buffer submissions to queues. The status of fence is only visible to CPU. Semaphores being generally associated with resources or group of resources and can be used to marshal ownership of shared data. Their status is not visible to the CPU and only visible by GPU. Events providing a synchronization both on GPU and CPU and can be waited upon by either. Barriers providing execution and memory synchronization between sets of command buffers and only visible to GPU. In this part, we need to create 2 semaphores for rendering. Let's create semaphore createInfo and just set vk structure type semaphore createInfo to S-type. Now call vk create semaphore in order to create Vulkan semaphore object. The first parameter is Vulkan device. Pass semaphore createInfo by reference as second parameter. For the third parameter, we can pass null pointer unless we want to set a callback for this function. And finally, for fourth parameter, pass our Vulkan semaphore object by reference. In case of having any unexpected problem, make sure to check the return result of this function in order to print out message into the output. This semaphore is used for checking once the image of swap chain is ready. Do the same for the next semaphore. The next semaphore is needed for checking when present process is done by the swap chain. After we created both semaphores, we should get queues from device by passing queueIndex. We've already defined 4 queues in device class. 1 for presenting, 1 for computing, 1 for transferring, and 1 for sparse. Now it's time to push our device object to vector of devices. Okay, now we need to create a render path for our project. This is in fact something that we will talk about in our next video. In the next video, we are going to create render path and frame buffer.